Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon. Welcome back to MAHSA International Technology and Engineering Conference, Mi-TEC 2022. Hi, I'm Ms. Farah. So we are now in the closing ceremony. I believe that all participants have presented their papers. So now, without further ado, we will proceed with the evening keynote session. So for this evening keynote session, we really have a very experienced speaker, which is from Qatar. Okay, so I will introduce our speaker today. Professor Dr. Abdelmagid Hamouda is the Professor and Associate Dean for Academic Affairs, College of Engineering, Qatar University. He is a member of the American Society of Mechanical Engineering, ASME, senior member of Institute of Industrial Engineering, IEIE, USA, and member of the Institute of Highway Transportation, UK, and a member of American Society of Engineering Education, ASEE, USA. He has published over 400 articles, of which over 200 are in well-reputed international journals, and has edited several conference proceedings. He is regularly invited as keynote and invited speaker for various conferences, seminars, and workshops. He holds multiple US and Malaysian patents. During the last 5 years, he and his team were granted 5 US patents. His research focuses on engineering materials and design, quality and reliability, engineering, artificial intelligence, and process optimization, as well as engineering education. He is currently managing research fund worth over 1 million. His research has been funded by the Qatar National Research Fund, Qatar University, Shell Company, ExxonMobil, Maersk, Marubeni, UPM, Mosti, among others. So Dr. Hamouda was the recipient of the Silver Award, second place at the Arab Business Plan competition among 3,000 competitors in Amman, Jordan. He and his team won Outstanding Paper Award in the Emerald Literacy Awards for Excellence 2019 and 2020 for their papers published in Journal of Applied Research in Higher Education. He was honored with the prestigious Takrim Scientific and Technological Achievement Award in 2010. This is the highest award for the scientific and technological achievement for Arab scientists globally. He won the Qatar University Merit Award for the years 2010, 2014, and 2020. This makes him the first and only faculty in the university history to hold this merit award 3 times. Congratulations, Prof. So also, he was winner for QU Research Excellence Award in 2016 and QU Service Award 2021. Most recently, Prof. Hamouda was listed in top 2% highly researcher in the world by Stanford University and Elsevier, USA, 2020 and 2021. So with Prof. Abdelmagid today is Mr. Abdullah Al-Hajri, a manager at a main gas company called Qatar Gas. So our speaker today, both of them have a very well-known prestigious award. So without further ado, we will proceed with the keynote speech by them. With all respect, please welcome.
Hello, good afternoon. Do you hear me clear? Hello, good afternoon. Good afternoon. I'm not sure if you hear me clear, Dr. Hamouda. Hello? 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 Hello?
Okay, your voice is clear.
Your voice is very clear.
So you hear me, yes?
Okay, you can start your now.
Okay, good afternoon.
So Abdullah, you can start now.
Yes, good afternoon, everyone. I would like to thank you for giving us this opportunity today. Dr. Abdelmagid will open the presentation, then he will hand it over to me. Dr. Abdelmagid, floor is yours. Can you go to the next slide, please? Okay, are you gonna present the slides, or you want me to present it? Just give me a second, and I'll prepare the slide presentations. Sorry for this technical issues. I'll take it over just now. I'm sharing the slides. Hello, I'm going to take you through our presentation today. Our presentations will cover, toward the oil and gas 4.0 challenges and opportunity. This is to be presented by Professor Abdelmagid Hamouda and myself, Abdullah Al-Hajri. Currently, I'm a PhD student in the final year at Qatar University. I'm going to take you through the agenda for the slide. So, can you see the slides clearly? Okay, I'm gonna take you through understanding of the global agenda and the global challenges of R&D. High overview of the oil and gas processing in a global market. The rise of the 4.0 industry and 5.0 and the future. Digital transformation in the oil and gas over the next decade. The future skills needs and required by 2025, the future job market outlook, and how the technology is driving us or US growth. After that, overview of the research productivity and concluding by the remark. So just to explain to you where we are, and we are coming from state of Qatar. It's an independent state in the Middle East, and it has got emerged one of the world's most important producers of the oil and gas. Since 2013, Sheikh, His Highness Sheikh Tamim bin Hamad become the governor for the state. Doha is the capital of state of Qatar, and most of the popular cities and some of the major cities in Doha are Al-Wakra, Rayyan, Dukhan, Shimal, Said, known as the first industrial city, and Ras Laffan is the biggest and largest industrial city. Also, we have several big islands such as Halul, Shra'o, and that stuff. In Qatar, populations in January 2022 was 2.8 million. So this is an overall about state of Qatar. High level about the institute or Qatar University. Qatar University is the first higher education institute in the state of Qatar. It has been the educational pioneer since 1977. Currently, it has got or boast their population over 23,000 students from 100 different nationalities and alumni exceeding 40,000. Qatar University has got an institution collaboration with the 135 institute in Asia Pacific, 54 in Middle East, 140 in Europe, 33 in Africa, 3 in South America, and roughly 128 in North America. This shows where the Qatar University rank using QS. The director of the universities and the board of directors has put an ambition and vision for them to take the universities from the current ranking in 2015 towards to be the best 100 university in the world. And if you can see the journey, it's very challenging, very difficult from 2015, and it has been jumped from 551 to 600 up to 224 in 2022. This is a very big jump. We have become as one of the top 250 university in the world, and our aim to be top 100. And then our ambition to go closer and closer, and inshallah with all the collaborations of the faculty members and students, we will be inshallah. On the Shanghai Worldwide University, the subject ranking, telecommunications has been top of the 50 in the world, and automation control subject top 100 to 150. This is a phrase from Albert, Einstein. What he said that we cannot solve the problem by using the same kind of thinking we use when we create them. So we need to think outside the box to ensure that the problem can be solved. And this is our theme and dilemma. Also, John Kennedy, phrase saying that changing is the law of the life. Those who look only at the past or the present, or they are missing, or certainly they will miss the future. So we need to think and plan for the future to ensure that there is a change in our life. The founder of Facebook, phrase the biggest risk is not only taking the risk, it's changing quickly. The only strategy is guaranteed to fail is not taking the risk. So this is what will enhancing us to make a change in our lifestyle and our thinking. Digital economy is the thing which everyone is talking about it in all of the forms, and industry and academia are talking about the new digital economy. The technologists, are saying that the new digital economy is the advanced robotics, factory automations, advanced manufacturing, Internet of Thinking, artificial intelligence, big data, cloud computing. So those are the new digital economy which we are referring to or talking about. From the globe, we've seen that the digital economy is approaching a critical tipping point. By 2023, the global economy will be finally reach a digital supremacy, with more than half of all the GDPs worldwide driven by the products and services from a digital transformed enterprise. Having said that, one of the challenges or the grand challenges of engineering is innovations or century of innovations. As all of you know, the grand challenges has been driven by a different thinking or thinkers in the world, specialists, where they are feeling that those grand challenges can be solved on the futures. Some of those grand challenges talking about the technology is personal, advanced learning, healthcare informations, managing, the nitrogen, develop the carbon sequestrations methods, reverse engineering of the brain, the virtual reality, cyber security. So there is a lot of things on the area of digital transformations and industry for 4.0, which is will solve the grand challenges. As you know, we came across a history of the revolutions in the industry, talking about Industry 1.0, where that happening in 1780, where the industry are production based on the machines powered by water and steam. In 1870, roughly, that's 2.0 industrial revolutions, where the most of the productions using the assembly lines. An innovative way has taken the industry to 3.0, where the automations using electronics and computers. There is what they call 3.5 in 1980s, and that in the area where globalization is happening and offshore of productions at the low cost of economies, where the industry goes offshore to a different countries to cost-effective method of production. Today we're talking about digitalizations, which is connecting devices together, data analysis using those devices and the artificial intelligence and technologies, automations, and sophisticated digital tools that use. Academia and some of the experts are talking about 5.0, which is the future, which is the fifth industrial revolutions, or which will be focusing on the cooperations between the man and the machine as a human intelligence. This is the journey and the future of the industry revolution. Now, where we are, Industry 4.0, it's the Internet of Data and Internet of People, Internet of Service, and Internet of Things, such as smart mobility, buildings, smart homes, social webs, business, cloud, smart factories, and smart grid and logistics. Here in this slide, I'm gonna a high level take you about what is the oil and gas. Oil and gas has got several sectors or several segments where we call it in the industry upstream, midstream, and downstream. Upstream is oil and gas explorations and productions, where the gas and oil came from the wells, either onshore or offshore wells, and that has been transferred or transported to the midstream or processing areas, where those hydrocarbon will be processed depends on their natures, either crude oil or natural gas, or liquefying natural gas. Then it will be manufactured in the midstream. It will be stored, and then it will be transferred by pipelines or by vehicles. Those products is not a final products. We called in the industry something about a downstream, where those products are refined more and more to have a valuable products, and this is what we call the downstream industry, such as the refinery and distributions to the market, sales and retails. Here we can see the technologies or the explanations of the technologies. On the last few years, we've seen there is a booming on those technologies, talking about blockchain, nanotechnologies, 3D printing, sensoring, artificial intelligence, robotics, and drones, and then we have seen there is a growth on the industry in the last few years using some of those technologies. Also, the technology developments is expedite or speeding up, and the human factor on it, the developments, and the use of those technologies is increasing a lot. Now we will ask ourselves, what is the oil and gas 4.0? It's the implementation of using the digitalizations, connecting the dot together, using a big data and automations, and the Internet of Things together on the oil and gas industry. This opportunity is raising the demand and driving the major oil and gas to produce and evolve and change and cost-effective solutions, which will lead to maximize the utilizations, optimizations, and reduce the cost by using those kind of technologies and artificial intelligence. The next decades of the digital transformations in oil and gas are coming across roughly 4 themes on the digital transformations, and those themes are shows here, like digitalization or digital of the asset lifecycle management, where the new technologies will be combined with the data-driven insight. This could help on boosting the agility and take strategic decisions and resulting in the new business models. Also, the collaborative ecosystem, by applying those integrated digital platforms to enhance the collaborations among the ecosystem participants, and this will fast track the innovations, reduce the cost, and providing an operational transparencies and optimizations. The third theme is what we call beyond the parallel, which means that to work on innovative methodologies or models for the customer engagements, which gonna offer the flexibility and personalize the experience. And this will open the new opportunities or revenue opportunities for all the oil and gas operators, and a new service for their customers. The fourth one, or the fourth theme, is going to be energizing the new energies, where the digitalizations of the energy systems will promote the new energy sources and carriers, and support the innovative models for optimization and making energy, and to remain relevant to the customers of the oil and gas industry, and understanding the full impact of those changes on the border of the energy system. The fourth theme has got several initiatives, and those initiatives I'm going to take you through it quickly. On the digital asset lifecycle management theme, several initiatives are ongoing, like the new era of automations, the advanced analytics and modeling, and connecting the worker. This will be using technologies of automations on the operations, and using the robots. Also remote operation center, where all the industry or the plant will be connected to a one centralized system. Predictive maintenance, which will help the maintenance guy to predict when is the next due for maintenance, if the equipments or machines are due to the current operation circumstances, and will help to minimize the shutdowns or unavailability of those equipments and machines. Operation optimizations, again, this is the advanced data, where we're going to increase the profitability and optimize the productions of operations, depends on the market. And wearable, where we are talking about the art, the virtual reality, and the smart helmet, where the operator or a worker can go to the site, and he can visualize what's happening, and he can also receive the information from his supervisor somewhere outside the plant. On the second theme, on the collaborative ecosystem, is the digital information sharing and operation transparency by using the blockchain and smart controls, and the real-time supply and demand by 3D printing and additive manufacturing. Beyond apparel, the initiative talking about digital customer services, and some of the technology like hyperlocal mobile fuel options, and the second initiative is omni-channel retail and experiential services by targeted digital marketing. The final or the last theme, by energizing the new energies, consumer energy choices, and this technology will be like alternative energy choices and platform. Now, if we ask ourselves a question, how this technology are going to drive the oil and gas productions in upstream? This will be a core part of the explorations. We're using a 4D printing for seismic imaging, and this will help in the data analytics and visualizations model to ensure that the reservoir data are available, and this will integrate it to the production map, and it will change and shows all the changes in the reservoir, and the level of the reservoir, and those advanced things will be giving decision maker more precise amount of the quantity of the resources available, and it will help them for the future explorations and industry productions. Also, how the technology is going to help or driving the oil and gas and the production, the midstream, and the transportations. Using the smart sensoring, thermal detector. This is can help and provide the real time data and monitor the key safety features. This will minimize, the risk of leaks and safety incident. Also, using the smart sensors, this is could detect any leaks in the process of the pipeline earlier than the incident happened, by using those variables of the pressure, temperature, and any deformations for the pipeline infrastructure. And the storage, the key areas for transformations, including the data management to track the inventory level, also, and monitor the system to ensure that what is coming from the production lines are going and having the capacity in the storage. Otherwise, it will lead to what they call a tank top, which may impact the production or shut down the plant. Also, there is several things that are used, like the connectivity, drone surfaces, and some of the tools or technologies are explained areas. So we use this in oil and gas. We use drones. We use virtual reality, and data management, or big data, cloud. So it's matter of connecting and transforming the oil and gas to the new era of the industry 4.0. And downstream refining, the smart sensoring also enhance the monitoring of the safety and functionality of the processing. Also, predictive analytics help the distributions, equipment to forecast the demands and to ensure greater accuracy of the availability of the resources and a production level. I'll hand it over to Dr. Abdelmagid now to elaborate on this. Dr. Abdelmagid. Dr. Abdelmagid. Okay, I'll continue then if he can step in. Otherwise, I'm going to. Yes, Doctor, can you go ahead?
I'm trying. Can you hear me now?
Yes, we can hear you. Floor is yours, Dr. Abdelmagid.
Okay, thank you. So I can move the slides from my side. First of all, I would like to thank the organizers for inviting us to this presentation, and we are seriously sorry about the technological challenge that we faced at the beginning. Especially, I would like to thank Professor Abdul for inviting us to this presentation. I think my colleague Abdullah did an excellent job to manage the earlier part of the slide. Now here I'm just taking over in terms of AI usage and implementation within oil and gas and other sectors. So I think it's really exponential now, and it caters for. Can you move on, Abdullah, the slides? I cannot move the slides from my side. Yes. I cannot see the slide, Abdullah. Okay, now I can see it. So basically, AI. Go next slide, Abdullah, please. Okay. So AI is really now, especially the part of AI which is related to machine learning. It's really heavily been implemented recently in digitizing the processes, looking at energy trade and risk management, looking at the customer relationship management, look at ERP and other types. So it is really taking a lot of interest from oil and gas companies to implement AI and specifically machine learning in this. Next slide, please. Now, I think here we are talking about automation and the use of automation in the global arena. So basically, this is a very big interest, especially in the US. So it is there is a committee from the US House of Representatives that's focusing in the Energy and Commerce Committee, and they really develop a number of disturber series related to advanced robotics, and they see this is a big investment that need to be looked at. The next slide. So it shows the growth and the demand in terms of robots over the last couple of years, from 2009 to 2019. So there is really a steady growth in terms of the need for industrialized robot. Next, Abdullah. Now here we're looking at most of the demand is coming from the Asian region. So basically Asia and Australia are the main operators of this industrial robot. Next, please. And here we're trying to shed the light about where this industrial robot has been used. They are mostly used in the logistics, so which is area of interest also to the oil and gas industry. So we can see there's a big growth from 52,000 to almost 250,000 robots being dedicated to logistics. Only that's over the 2 years, 2018, 2019. Next, please. And from this, we can see there is adaptation of the Internet of Things that's related to robot, industrial cybersecurity, for automation, big data, open automation, that's also being implemented in the last couple of years. Virtual solution also becomes, as also referred by my colleagues. So collaborative robots, it's an area which of increasing growth recently. So where you have collaborative robots. Again, since we are running out of time, I will go very quickly. So here we talk about 3D printing and additives, how oil and gas really the sector is getting into this. They're really left behind. If I compare the usage and the application of 3D printing and additive manufacturing within automotive and aerospace, it's not comparable to oil and gas. However, recently, this is a project that we are running with Taxi and Coal Station, etc., about really having a supply of 3D printed parts for oil and gas industry in case of any another pandemic or another disaster. So basically, this is part of building resilience within the oil and gas industry. Next, please. Again, this is, as I mentioned, additive manufacturing is a big thing, and it's almost worth of over $30 billion US. Next, Abdullah, just to next, I think this is just to show the revenue. This is the area where 3D printing and additive manufacturing being used in oil and gas industry. So there is a high potential. That's the upper left, where it can be used in drilling. Drones. You can move. So drones is another area of heavy usage by oil and gas industry in the last 10 years. We do have a number of projects related to using drones and collecting data. As you know, oil and gas company, they are not only producing oil or gas, they're producing oil and gas, but also they produce data. So this is data becomes an asset that can be used to really improve the processes, make things more efficient, and so on. Next, Abdullah. Next. Now this shows the U.S. commercial drone market. So there is a huge market in the drones, especially if you look at it here. A lot of focus in the defense. However, the green part is related to the civilian applications. So it's really growing, but however, growing at a gradual level. Again, drones are used mostly now in the pipelines, inspection, and others. But I think there is a lot of potential. These drones can be used later in the future. Next. Now, this is an exercise we did very quickly last couple of weeks, where we look at the growth in the number of publications which are indexed in Scopus that related to robotics and its application. There's really global growth in this one, with an over almost 75,000 index publication only related to robotics and its application. Next, please. As expected, countries related that are really publishing a lot in this area, I can see US, China, and Germany. They are the leading three, followed by UK, Japan, Italy, and so on. So these are the main players in terms of research related to robotics and its application. Here, I try to only focus in OIC countries. So we look at here countries like Iran, Malaysia, Turkey, and other Arab countries. So next, please. So out of the 75,000 that are published, roughly around 3,700 only that are produced from the OIC countries. And if I look at the main producers are really the top three is Iran, Malaysia, and Turkey. So these are followed by Saudi Arabia. These are the main really active research groups within this robotics and application. Next. Here again, we are trying to look at robotics and AI. So area which is a combination of use of AI within robotics. So we can notice that since 2016, 2017, there is really an exponential or almost vertical growth in research activity within this area, and AI becomes the thing that everybody talks about. Again, typically US, UK, China, Germany are the leading research groups in this area. Next, please. If I look at OIC countries, next, please. So again, it's the same. After 2016, there's a lot of activity, but Malaysia is taking the lead in this one, followed by Turkey and Saudi Arabia. So these three countries are really active in this one. If we talk about the topic that of our very directly relevant to our presentation today, we talk about digital transformation on oil and or gas. So there is global interest from 2018, 2019. It becomes a lot of activity related or a lot of research publications. This is again led by the US, China, and Russian Federation, followed by Germany. Next, please. Now, activities related to fourth industrial revolutions, again, I think it's expected since the terminology and the coining of this fourth industrial revolution start by the World Economic Forum in 2015, 2016. Germany is really taking the lead in this one, especially in the fourth industrial revolution. When I talk about OIC's countries, Indonesia and Malaysia, followed by Turkey, are the main players in this one. Next, please. Again, I think when we add resilience to the fourth industrial revolution, we are coining something. It's especially in Europe, they talk about the fifth industrial revolution now. Now, this is research activity at early stages, so it's not much research being done so far because it's a new trend. When we talk about OIC countries, Turkey and Malaysia is taking the lead in this fifth industrial revolution even. Next. Here we touch a little bit about the Global Competitiveness Report, which is recently published by the World Economic Forum. What I want to see from this one, I think you look at it has 4 pillars. So we talk about ICT adaptation, flexibility, and digital skills, as well as digital legal framework. You can see that the countries that they might have very good ICT adaptation, but they may be lacking things related to the digital skills. So in terms of Qatar, for example, it has a very ranked number 9 globally in terms of ICT adaptation, but it's not like ranked among the top 10 when you talk about the skills, readiness, and the availability of skills in this one. Next, please, Abdul. This is very good report. It is published by the International Institute of Management and Development World. It is talk about really digital. So if I take, for example, Malaysia and Qatar, they are ranked among the top. Malaysia is ranked 26 the last 2 years. Qatar is ranked improved from 31 to 30. Next. Now, this is again the same flow chart, but just over the last 3 years. So we can see easily here. As mentioned by my colleague Abdullah, related to fourth industrial revolution or oil and gas 4.0, I think the need for skilled graduate to join ready for oil and gas company is very important. So if I look at the top 10 skills needed by 2025 according to the World Economic Forum, I think complex problem solving, critical thinking, creativity, these are things that are building up. Next, please. Again, so when we talk about the job market, present and the future here, soft skills are very critical. And to be honest, a lot of people, they think soft skills are easy to acquire, which is to be many people, especially the recent report by Harvard Business School, they say maybe is one of the most difficult to have, is really have soft skills to our graduate, as well as hard skills. Now there is also big data and data analytics becomes knowledge in this area becomes very critical. So to have a graduate ready to join the oil and gas 4.0, they need to have some knowledge in big data and data analytics. Now there is a report which is published last year. We'll talk about the global tenant competitive index. So this is very good report, and the report here basically looking at the global rank of countries, like in as well as the vocational skills needed, as well as the global knowledge related to leadership and management skills. So we have two types of skills here: the vocational and the hands-on experience skills, as well as the global management and leadership skills. So you may have countries that next please, it's okay, I can. When we talk about recruitment of university graduate by companies, I think the most important skills needed, at least the one name based on the survey, they say top 5 is ability to work in team, ability to work with a wide variety of people. Here talk about diversity, different culture, ability to solve complex problems, ability to build, sustain, and expand the network of people, time management, and ability to prioritize. Okay, next, please. These are the important ones, but there are also skills are important but difficult really to recruit student with, or to recruit a graduate with these abilities: ability to influence others, ability to have strategic thinking, drive and resilience, flexibility, big data analytics I mentioned before, as well as ability to solve complex problems. Next, please. I think here is you can go next. I think it's the same message. Now there was a survey was done by almost 8,000 executives from different parts of the continent, for different continent, and the survey they concluded that there are a lot of graduates that are really, if we talk about 85% of companies, they are really managed to, because of COVID-19, they managed to accelerate digitization. So because of what happens, the pandemic, when they are asked, almost 85% they managed to really accelerate their digitization strategies. 67% of companies have accelerated automation also, as well as usage of IT. So I think the pandemic was somehow is an enabler to force companies, even universities and other institutions, to move on with digitization and the use of artificial intelligence. So it did accelerate the process. Next, please. Now, can we predict the future? Again, it may be impossible to predict. However, it will force us to at least envision about tomorrow by becoming more available to embrace change, adaptability, and innovation. So these three words can be combined in being resilient, being flexible. Now, top 4 barriers for digital leaders, I think, as mentioned before, lack of required skills in the organization. A lot of them, they say it's skills. Cybersecurity is really of a big concern to companies. Lack of awareness among senior management, because they are the one who making decisions. So if the senior management are not fully, they have mindset change and aware of it, they may slow the process of adaptation. Again, old-fashioned organization. Most of oil companies and gas companies, they are built long time ago. So basically, this old-fashioned organization and culture is difficult to change. Next, please. I will go very quick concluding remarks that we can close with. I think digital transformation or the oil and gas, if we specific, is a must for especially for developing countries. And we can also say government has to play a major role in this because we cannot rely only on the private sector to lead it. And this maybe happen in some parts of the world, things like Malaysia, UAE, Qatar, Saudi Arabia, Oman. I think these countries are really government playing a good role to embrace and move on digital transformation. Oil and gas needs a really adaptation before digital transformation. To adaptation is very critical as they need to install, as they are really installed long time ago, as I mentioned. So all these facilities being built long time ago, now you need to get adapted before to really embrace digital transformation. It's important also to start as early as possible because I think there is a lack of new talent and skills, lack of digital culture within, and that's need training. So the earlier you start is better. I think research productivity, as I mentioned in my earlier slides related to OIC countries, I think if I compare it with the global trend, it's a very small percentage. So I think that in these countries, research productivity, especially the indexed one, need to have a big boost. Okay, next please. Resilience or we call it AR4 is very important in developing countries, especially when we talk about critical infrastructure that countries are relying heavily on related to oil and gas, energy, utility, and etc. Government should champion, as I mentioned before, the fourth industrial revolution with the support from the institutions like higher education, research centers, and with the adaptation of big data, machine learning, and the predictive technologies, business can really overcome many of today's challenges. Next, please. Specific features that really, when you talk about that can make oil and gas really a good example for adaptation of fourth industrial revolution is actually the remote location of these ones, the safety issue of concern. So that make implementation of automation is very critical to oil and gas. According to the International Energy Agency, the widespread use of existing digital technology could decrease production costs by between 10 to 20%. So I think within adaptation of the digital transformation, companies can really cut their costs between 10 to 20%. The oil and gas company is very capital intensive. So a large project, they can typically take many years to develop. However, digital transformation or digital technology involve faster, so it's difficult to introduce design changes in between. So you need to have a trade-in because these projects, as I mentioned, the oil and gas companies' projects are large, capital intensive. When you talk about the technological or digital companies, they are really evolving very fast with the technology. So you need to have a good balance to introduce the design change. Aside from the economical and technical reasons, there is also management, as I mentioned before. So high-level management approvals is important. So the mindset and the change is very critical. The oil and gas 4.0 concept require well-developed infrastructure, IT infrastructure. In some countries, it's available. However, we need also well-trained, skilled workforce, which is the most important, at least for now. The readiness for decision-making to introduce the innovative approach. Next up. I will end up with one next. So if you can really pick up where is the face? So it says that if you pick it within 3 seconds, you are using your right half brain, which is maybe in my case, I was not, maybe because of glasses, but I can, I'm sure some of you, they picked it. So it is really here. You can see the face among the next, Abdullah. We would like also to welcome you to Qatar in November, December, inshallah, for the World Cup 2022. And with this, thank you very much. Thank you.
Thank you very much, Prof. Abdelmagid, for your interesting speech, and also Mr. Abdul for the very interesting information. So We humbly appreciate your presence and share your amazing knowledge with us. And with this, I would like to show you the e-certificate that we prepare as our appreciation to you. So this e-cert will be sent to you after the ceremony.
Thank you very much. Thank you.
You're most welcome, Prof. Abdelmagid.
Thank you.
Okay, dear audience, next keynote speech is going to be delivered by Professor IR, Dr. C.W. Lee, the Professor, Department of Architecture and Civil Engineering, City University of Hong Kong. So let me introduce Professor IR, Dr. C.W. Lee, earned a bachelor's degree from University of Technology Malaysia, a master's degree from National University of Singapore, and a doctorate from Nanyang Technological University. He worked as a postdoctoral research fellow at the University of Queensland and the University of Hong Kong. He is currently a fellow of ASME, ASC, CMI, and HKIE, and a professor at the Department of Architecture and Civil Engineering, City University of Hong Kong. He is also a registered professional engineer. Professor Dr. Lee teaches at various universities worldwide as a visiting professor. Recently, Professor Lim was awarded the prestigious 2020 J.N. Reddy Medal as recognition for significant and original contributions to vibrations of plates and shells, smart piezoelectric structure, nanomechanics, and sympathetic elasticity. So without further ado, Professor Lim, with all respect, please welcome.
Thank you. Thank you very much, Chairman. First of all, my very much appreciation. Let me share my screen first. Let me share my screen. Share screen. Is it okay? Can you see my screen? Hello? Hello, can you see my screen, PowerPoint screen? Hello? Any problem or not? I suppose there's no problem. So first of all, my very much appreciation to the chairman and also to Professor Dr. Aziz and Dr. Hushnie for inviting me to this wonderful event of MAHSA conference, International Technology and Engineering Conference. Thank you to the chairman for introducing me to you. Indeed, I'm a anak Malaysia, and I'm still a Malaysia, and I return to Malaysia every year, except the last 2 years since the pandemic erupted, or the pandemic broke out. Last 2 years, I have been very much willing to return, but yet because I'm now in Hong Kong, the condition here is very tight. Unlike Malaysia, it's now already loosened, but in Hong Kong here, it's still very tight. So I'm still waiting for when the condition is loosened a little bit, and I'm very willing to return home to visit my friends and family again, and perhaps to visit MAHSA in the near future. So before, let me go on to my talk today. The talk I'm going to present today is on the seismic metamaterials with low frequency wide band gap using steel barriers. It is a work that I have completed with my PhD student Mohamad. Mohamad now he graduated about half a year ago, and is now a postdoc in Dublin in Ireland. Perhaps this is the key points, some of the key areas I will share with you today. I will start with background, and then I will go to the metamaterials, template, pillar and trampoline, and steel barriers before I make a conclusion. Of course, I also acknowledge some of my students for having spent lots of time here in this work. Metamaterials, some of you may know or may not, but let me just briefly give a quick description to you. Metamaterials is indeed metamaterials are not natural materials. When we talk about iron, when we talk about composite, not composite, we talk about what kind of aluminium, steel, and kind of that. These are materials that we can either manufacture or we can obtain from natural resources. However, for metamaterials, although I think the name is a little bit misleading. Metamaterials is indeed not a material. It's a kind of design. We can design metamaterials using either steels, we can use composite, we can use aluminum, we can use polymer, we can use any other we can use any natural materials we found from the earth, and with special design, then we will obtain a kind of special design called metamaterials. As you may see here, this is a kind of metamaterial, which is indeed not material. It's a design of many small components of isotropic or composite material. So this could be a kind of triangular design. I will show you later. So with this kind of metamaterials or designs, then we will be able to achieve certain special characteristics, either dynamic or either electromagnetic or either acoustic or either a light or something else. That means we will be able to achieve certain physical phenomena or certain physical response that natural materials are unable to achieve. For instance, in our undergraduate studies, we know that the Poisson ratio for a material like steel 0.3, aluminum 0.33. Oh, that means the Poisson ratio is always positive. We can never have a material with a negative Poisson ratio. However, if we design metamaterials, we will be able to tune the Poisson ratio to the negative regime. That means we are able to create something that will behave like having a negative Poisson ratio. For in another instance, where we know that the refractive index of any physical between the interface of two different physical media, the refractive index is always positive. It can never be negative. But using metamaterials, when the waves come here, it will reflect negative to this direction. But using natural materials, you always go this way. You will never be going that way. So that means metamaterials is a kind of special design so that we can achieve something extra, something previously inconceivable or previously impossible. So I wish also to draw your attention that many living beings in the world today, or you may not be aware that they have certain body parts that are designed to behave like metamaterials. For instance, butterfly, an insect, a bug, or sometimes in their body parts they have some kind of a special features in their body such that they will be able to reflect wave, or they will be able to reflect acoustics or sounds, ultrasound or audible sound in a way that pure acoustic wave can never achieve. So I just want to show you that their designs will be able to function in a way that to achieve the objective they want. In other example, this is a kind of electromagnetic wave. Okay, so this is permittivity of the electromagnetic wave. This is permeability. So when both coefficients are positive, we have a wave that is propagating outward. When we have one of them positive and the other negative, then it becomes a band gap. Band gap meaning that the wave cannot even though there is an excitation wave, the wave will decay or will dissipate within locally and will never go out. When both of them are negative, then we have a backward traveling wave towards the one point. So by tuning these values, we will be able to achieve certain functions. In most cases, when we design metamaterials, as far as my area is concerned, I'm doing vibration, wave propagation. We want to achieve this part. We want to create a band gap such that wave cannot go through. When wave doesn't go through, it means this part of the area is free from any incoming wave. Or even though there's an internal wave, the wave cannot go out. Or when there's an external wave coming in, the wave will not go in. So therefore, this part of the band gap is protected from external this wave disturbance. In my talk today, in particular, I want to show you that by having some kind of materials around a building, we are able to protect. I don't want to say seismic, but seismic is too strong. Okay, I just want to say that if there is a bomb or there is a minor bomb, not a nuclear bomb. Okay, if there's a bomb in some part near the building, when we have a building that is protected by metamaterials, the external disturbance or strong explosion outside, when the wave comes near to the building, it will be somehow diverted. We are not absorbing the wave. Metamaterials cannot absorb wave. Okay, if it absorb wave, that means it is a damper. We are not creating a damper. We are creating metamaterials to channel the wave away. This is our purpose. We don't want the wave to come in. That means we are going to divert the wave somewhere else. So for instance, we can also have metamaterials which we can guide the wave here, so we can detect if this is a defect, or like a crack or like a damage. So we will be able to see that there is a wave damage here if wave cannot go through. Or we can also design, this is a metamaterials, every part, okay? So we can design such that the wave will go through in this direction. So in this is a numerical simulation. When in this part of the wave, it is a band gap. So you can see that when we're traveling here, it becomes suddenly very large. So this part is a pass band. Pass band means wave can go through, but this part is band gap, wave cannot go through. This is another example. We can divert the wave into two channels, or we can focus a wave, or we can actually, this is very important. If you see this part of this one can be a piece of land. This part of the building, this part of the land is protected by metamaterials. So you can see that wave comes here. The wave cannot penetrate through this area because it's protected by metamaterial. However, wave go through every other parts where metamaterials are not available. So this is, in the previous case, some of the examples I showed you did not come from me. I got it from some other resources. But here, these are some of the work that I've done. In my work with my students, we design a metamaterial such that we can guide wave along this direction. I want to assure you, or I want to emphasize to you that by diverting the wave, it's different from reflection. It's different from when we place a mirror. If we place a mirror here, wave can also be reflected. By all means, wave can be reflected by any kind of boundary, or mirror, or you want to call it mirror or any kind of boundary, wave can be reflected. That is for sure. But having metamaterials, when we reflect the wave, the reflection is, in theory, the reflection is 100%. That means there is no loss of energy, there is no absorption of energy, there is no penetration energy, or whatever it is. If you place a boundary here and you reflect the wave, when there is a reflection by a force boundary, then there will be absorption of energy. There will come back, all others are. That is not what we want. We don't want to have force reflection. Force reflection is not metamaterial. So in this case, we simply have special design here such that the wave will be reflected 100% in theory and then back this way. Similarly, we can also have wave reflecting with a negative refractive index. So this is again another super lens and also wave attenuation. This is very important, is what I do. I'm going to share with you today. Yes, here. Now you may see that this building here, there are two buildings here. One is this part is without metamaterials around, but this building here is surrounded by metamaterials. So when there is an external wave, I don't want to say earthquake is too strong, but metamaterials will be damaged somehow if the earthquake is too strong. If there is a bomb or there's an explosion here, if we have metamaterials here, the wave will be diverted deep into the ground. We are not absorbing the energy. We are diverting the energy deep into the ground. But for building without protection of metamaterials, it will be subjected to the wave damage. So this is kind of what I want to show you today. So metamaterials, this part of the metamaterials here, it can be simply some structures. It can be simply some structures like this, with columns of structures. So this is a metamaterials. You can see that when waves comes here, the wave will be diverted deep into the ground. We can also have metamaterials with randomly erected columns with different height and different spacing. However, when we have this kind of metamaterials, we need to design properly, or otherwise we won't be able to achieve the optimal kind of a structure we want. That means the diversion of wave may not be as strong as what we want. Here I wish to highlight to you that indeed, within a city, buildings around can also be somehow regarded as a kind of metamaterial. So metamaterials can be found, actually can be something that we don't realize, but it is around. Indeed, recently I published a paper that we can treat forests as a kind of metamaterials. That means within a city, if we plant trees around, but the trees must be carefully planted with specific spacing, specific height. Then this kind of tree can be treated as naturally available metamaterials. So forestation is not only for environment sustainability, it can also be a kind of metamaterials for protecting some special buildings that we want. So in this here, my metamaterials is a tin plate. I want to show you two different designs. One is tin plate, the other one is barriers. So for tin plate, we have a composite metamaterials. We have three different designs. The first design is a square column. This column is composed of two different metamaterials, the inner part and the outer part, which are squares. The second design are circular columns. We again with outer and inner composite column. The third kind is a cross-like metamaterials, whereby we have an outer part and meta part. You can see that these are the cross section. So we do at this moment we do a numeric analysis of these metamaterials to obtain the wave propagation feature. So in this case, we created a Brillouin zone. Brillouin zone is a kind of a wave frequency response in a two-dimensional domain. So in this case, a wave number in the x direction, wave number in the y direction. So it's a two-dimensional domain. So in this case, we need to find out the frequency response in the x direction, frequency response in the y direction, and also another frequency response with x, y, and y directions. So that means we need to find out the frequency response within this unit, because metamaterials is a kind of periodic structures. The design will actually periodic. That means it repeats itself many times. So that because of its periodicity, if we know the frequency response within the one unit, then it is the same. The frequency response will be the same throughout everywhere because it only repeats itself. Therefore, we only need to find out the frequency response within this, what we call the Brillouin zone. So this is a frequency response for the square section. A is the frequency response for A square section, the frequency response for the circular section, and the frequency response for the cross section. We can see that within this section, we have a total G. This part is the band gap. That means within this part, wave cannot go through. That means if we design our building within this region of the frequency, there will be no wave which can penetrate through. So our purpose here is we want to enlarge the frequency band gap as large as possible. So therefore, we found out the first band gap here, the second band gap here, but this band gap is not a total band gap. It is just a partial band gap. It is only the band gap in the x direction and only in the other xy direction, but there is no band gap in the y direction. So this band gap somehow is not too useful because it's only partially available. We need to find out a band gap which is completed throughout from xy and xy. Therefore, we can use it. So for square section, we have here. For circular section, we have here. And for cross-light section, we have here. Next page. Just a minute, the file is to be. Okay, so here is a frequency. After that, we also need to find out the effect of different material properties this is a geometric properties. If we want to increase the thickness of the wall, we want to increase the height of the wall, or you want to increase somehow different sizes of the wall. So here we explore when we change geometric parameters, how would it affect the band gap? So this is kind of, so in this case, if we have a reduced thickness, you may see that the band gap moves to a lower frequency. If we have a reduced thickness of concrete, you can see that the frequency band gap becomes larger and higher. So this is a further exploration is if we change the material properties, like we change the Young's modulus of concrete, what will happen? If we change the Young's modulus of the steel, what will happen? If we change the Young's modulus of silicon rubber, what will happen? So therefore, we play around with density, we play without density and Young's modulus for different. Here is the time history. Time history. Again, we have three different designs: a square case, a circular, and a cross-light. You may see that for square, we have a lower band gap here. Another is a second band gap, but the third band gap is only a partial band gap. It's not too useful. So for circular light, we also have a small band gap, but we have a larger second band gap. For the cross shape, this is the most useful because you may see that the band gap is very large. If the band gap is large, we will be able to protect the building for a larger, a wider frequency spectrum. The third part of my talk now is to see a different design: trampoline pillar and trampoline metamaterials. This is a different design of trampoline materials whereby we have a polymer down, like a membrane polymer, and on top of the polymer we have a kind of composite steel plus polymer. So we have two different designs. The first design is only we have a column on top of the membrane. Okay, so we simulate the membrane with mass and spring and damper. We form some governing equation. So this part, the column is only above the membrane. There is no column beneath it. But in our second design, so we obtain some frequency spectrum. In our second design, you may see that we have a different trampoline. A trampoline, as you may recall, a trampoline is a kind of a play toy for young kids who can jump on top of it, bounce up and down. So in this case, we are doing the same thing. This column, it can be bounced on top of the membrane, so it behaves like a trampoline. We can also have a different design whereby we cut away the mass. We have a reduced mass. So therefore, we have two different designs. We only trampoline on top of the membrane, but no column below. However, the second design is we have a mass on top of it and below it. We can also have a reduced mass for both designs. As you may see here, we also perform some numeric analysis. We found out that by having holes, what does it mean? By having holes means we reduce the mass. If we reduce the mass, therefore we have a bigger band gap. So having reduced mass would be, for certain reason, a better design. In this case, we find out what is a thickness ratio. This is a thickness. When we change the thickness ratio for certain geometry parameters, what happened to the frequency? As you may see, when we change the thickness from 0.35 to 0.95 thickness ratio, you may see that the frequency band gap becomes larger. And with this is pillar only without trampoline, but with trampoline, trampoline is from a lower part to the higher part. That means with trampoline, this part is extra. For the first band gap, for the band gap with trampoline, it is even larger. The trampoline part covers a pillar to the lower line to the upper line. So with trampoline, that means with the membrane which can bounce up and down, therefore we can enlarge the band gap. And this is what we want. Our design is we want to increase the band gap. So here is a time history. So the time history, you may see that this part of it is a band gap here. Lower, any part which is lower than here, it is a band gap. I wish to share you, before I make a conclusion, I want to show you another example, which is a steel barrier. This is a different design of metamaterial. In this case, we plant this structure below the ground. We have a part of it which is above ground and another part which is below ground. So we have we have different design. This is a I column. This is a cross column. So we have a I column, which is a cross column, two different design, and we also have lower part below the ground. This is we also do a theoretical analysis, but this theoretical is because of the complexity of the metamaterials. We are only able to do a simple modified theoretical model. In this case, again, we have a two-dimensional domain whereby we have the frequency wave number in the X, wave number in the Y, whereby we need to analyze the frequency response within the X, Y, and XY, so that we understand the wave frequency response within this Brillouin zone. We will understand everything because metamaterial is repeated materials. That means the structure or the design is repeated from one point to the next point to the other. It's like a cell. The cell just repeated itself. So if we understand the behavior of one single cell, we know the behavior of all other cells because it is just a repetition. Here, we consider two different kinds of soil. The first soil is a homogeneous soil layer. We have the Young's modulus, we have a density, and we have a Poisson ratio. So this is that means it's a standard or homogeneous, that means it's a pure, no changes, average soil. But the second type of soil is two different layers. We have a field, we have a clay, we have sandy, we have silt, sandy, and sandy clay. We use this, we follow this kind of soil, which is we refer to the coastal soil profile from coastal land in Shanghai, China. So we take a real example of the soil profile in China as an example in our numeric analysis. So having this, you can see that the top is a column and this is below the ground. Therefore, in this case, we will create a zone. This is a zone with a frequency response we want to analyze. This is a sound line, and above the sound line, there will be no band gap. So above the sound line, this region is useless. What we want to analyze is below the sound line. When we below the sound line, we will be able to identify which part is the band gap. So you may see that outside, it is this is a sound line in the X direction. This is a sound line in the Y direction. This is sound line in the XY direction. So within the sound line, we need to analyze. Outside the sound line is useless because there is no band gap. So within the sound line, this part is a band gap. This part is a band gap. Wave cannot go through, but this part wave can go through. So this part is useless. This part is useless. So the only useful part is this part and this part. This is for cross like this column design. This is also cross like, but this part is the single layer homogeneous soil. This is a 6-layer soil. So you may see that for 6-layer soil, according to the Shanghai soil profile, we have the first band gap, second band gap. The band gap becomes larger comparing to a single layer type of soil. This one is for cross column, and this is for I column. I column, we again for single layer and 6-layer soil profile. We have a very large second band gap and very a smaller band gap here. But for single layer, the band gap is kind of smaller. Finally, we also do a parametric study for single layer and homogeneous soil layer, whereby we understand the amplitude of vibration comparing to frequency for sample number 1 and sample number 2. And in this case, we want to do a simulation, and I want to show you the simulation. Here is the Metamaterials, and this is a 6-layer soil profile according to the Shanghai soil profile, and we have an excitation. That means we suddenly we have an explosion here, and we want to see when wave propagates along this section, what will happen to the wave. You may see that we analyze different frequencies: 0.5 hertz, 0.5 cycles, 10 cycles, and 1 hertz, and 2 hertz, and 12 hertz. We have we consider 2 different frequency ranges. As you may see that now here, the solid line is with metamaterial protection. The red line is without metamaterials. So you may see that if there is no metamaterial barriers, if the frequency extension is very large, that means a building will be subjected to huge wave impact. But with periodic barrier metamaterial protection, we have only a much smaller frequency response. This is for 0.5 hertz. This is also for 0.5 hertz. This is for 1 hertz. This is for 12 hertz. And you can see that if we have a frequency from as low as 0.5 hertz up to 12 hertz, we will have well protection if we have metamaterials. And we have, again, this is a sample number 2. The previous one is sample number 1, and this is sample number 2. As you may see, again, that with metamaterial or metabarriers protection, the wave impact would be very much reduced. Finally, this is a simulation, real-time simulation. As you may see that if there is a excitation or an explosion of wave here, when the wave comes to here, this is a metamaterial metabarriers, wave will penetrate to diverted deep into the ground. So therefore, our building to be protected, our focus to be protected should be built or constructed somewhere behind the metamaterial or beta barriers. As you may see, this one, wave will be penetrated, will be diverted deep into the ground. So again, I want to emphasize that this metamaterial is not designed to absorb or dam out the wave impact. It's not going to dam out the wave. It's going to divert the wave away so that some areas behind the metamaterials will be protected. So finally, this is my conclusion. So we have built up steel sections as seismic metamaterials. I don't want to overemphasize seismic because when we have an earthquake wave, the seismic excitation is too large. The energy is too large because our design is only limited to certain energy level. If the seismic waves is too large, all the metamaterial itself will be destroyed. So this seismic metamaterials is only, I don't want to overemphasize. There is a limit, but this part of work is still going on, and we hope that we will achieve better results in the future. The second point is attenuation of surface wave. The surface wave will be attenuated. Indeed, attenuation may not be a right word. It's a layman word. The wave actually is not attenuated. It is actually diverted to a different direction. Low frequency wide bandgap, yes. Because I deal with civil engineering. In civil engineering, the frequencies are always low. We don't deal with high frequency. High frequency is a electromagnetic wave or photonic crystals. They'll deal with light wave or electromagnetic. That would be a different level. I don't deal with that. I deal with low frequency waves. The competency of bandgap is validated by frequency and time domain analysis. More than 50% wave signal amplitude reduction. Our approach opens a new application of steel piling for seismic wave protection, not attenuation. Indeed, it is a kind of earthquake proof, and it is a low frequency. Okay, the interaction of soil with foundation is another challenge. Of course, just now I show you an example that refers to a Shanghai soil profile, but we can actually, there are many other different soil profiles that the challenge is ahead. Small, simple unit cell structures with low frequency bandgap is highly desirable. How to reduce the number of unit cells? That means the cost of metamaterials is yet another challenge that we want to explore. So we have published quite a number of papers in engineering structures, in physics letters, in European Journal of Mechanics, in engineering mechanical sciences, composite structures, and Acta Mechanica, Solida Sinica. And if you are interested, please write to me, and I'm happy to share my works with you. And this is a group of my PhD student. This is Mohamad. He did most part of the work, and he's now a postdoc in Dublin, Ireland. This is also a postdoc now. He's from Nigeria, completed, and this is another PhD who just graduated. This is Wiza Ahmad. Both Wiza Ahmad and Mohamad, they are from Pakistan. And this is Yang Chen Tim from China. This is myself. So this is a new postdoc in Hong Kong University of Science and Technology. This is my first PhD student. He's now an associate professor in Hong Kong in a different university. He's Dr. Lai. Okay, thank you very much. If you have any question, I'm happy to answer you. Hello.
Thank you very much, Prof.
Yes, I'm happy to answer any question if there is anyone who wish to know more a little bit about the subject. Or if you want, you may always write to me. My email is you can find out my email from my university website, or you can write to Professor Abdul or Dr. Hushnie, and they both of them have my email address.
Okay, Prof, if any questions, so we will forward to you.
Thank you very much. Yes. Sorry, it's
via
my pleasure.
Prof. Abdul Aziz. Okay, so we humbly appreciate your presence and share your amazing knowledge with us. And with this, I would like to show you the e-certificate that we prepare as our appreciation to you, Prof.
Thank you very much. It's a precious present from the organizer. I appreciate very much.
You're most welcome, Prof. We hope that we can see you here in Malaysia. Do you miss the nasi lemak and teh tarik, Prof?
Yes, certainly, certainly, very much, very
Yeah.
much.
So we hope that we can see you here in Malaysia. Anak
Thank
Malaysia,
you.
Prof. Yeah, we
Yes,
proud of you. Okay.
thank you very
So,
much.
yeah, you're welcome. Okay.
Okay,
So,
bye-bye.
bye. So, distinguished guests, ladies and gentlemen, next, let us welcome Professor IR Dr. Abdul Aziz bin Abdul Samad, the Chief Conference Chair for Mi-TEC 2022. With all respect, please welcome Prof.
Okay, thank you very much, Puan Farahin, and thank you very much for everybody concerned in making this conference a success. I think we had a very long day today, from from the opening up to the end of the keynote speeches by Prof. Majid and also Prof. Lim from Hong Kong, City Hong Kong. And we are very fortunate to have all the keynote speakers present today. And I must not forget Prof. Ali from UTM, and as I will repeat again, Prof. Majid and also Prof. Lim, our three keynote speakers who have kindly agreed to be part of our conference today. I must also give my appreciation to all the committee members, especially to Dr. Hushnie, who has worked tremendously hard in making sure that this conference today has been went well. I think it has went very well, and I'm also very happy to observe paper presenters today, not only from our local presenters, we also have international presenters from India. I'm happy to see that, and I was also in attendance to hear their presentation today from our colleagues in India. So they gave us a very good, a very good and very interesting presentation. But the rest of the rest of the presenters also, I know, gave a very good presentation. All of you have prepared well, and you have shared your knowledge with all of us today. And I'm sure all of us have learned a lot from this conference. So I will not take any further time. I'd like to thank you again. Firstly, to our Vice Chancellor, Dato' Ikram, our Prof. Research Director, Prof. Sri, our Dean of Faculty, Dr. Iman, for giving us this opportunity to have this conference today. And I look forward to have another conference in the very near future. So with that, I thank you again, and please stay safe, and we'll see you again in the near future. Thank you very much.
Thank you, Prof. IR Dr. Abdul Aziz bin Abdul Samad, for the speech. Now, I would like to welcome Dr. Mohamad Hushnie Haron, the Conference Chair of Mi-TEC 2022, for the Word of Thanks speech. Please welcome Dr. Hushnie.
Thank you very much, Ms. Farah. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Today has been a wonderful and amazing day as we have successfully had our Mi-TEC Conference 2022 with the theme Digital Transformation and Green Technology Towards IR 4.0. As the chairman of this conference, I would like to take this opportunity to express my deep appreciation to Prof. Datuk Dr. Ikram Shah bin Ismail, Vice Chancellor of MAHSA University, Dr. Iman Farshi, Dean Faculty of Engineering, Built Environment and Information Technology, MAHSA University, Prof. Dr. Sri Kumar Chakravarti, Director, Postgraduate Studies, Research and Innovation, MAHSA University, for their motivational and inspirational speeches during opening ceremony. A special thanks goes to our keynote speakers, Prof. Dr. Ali bin Slamat, with his title Higher Education 4.0, Current Status and Readiness in Meeting the Fourth Industrial Revolution Challenges, Prof. Dr. Abdelmagid Hamouda, and Mr. Abdullah Al-Hajri, with the title Towards Oil and Gas 4.0, Challenges and Opportunities. And then Prof. IR Dr. C.W. Lim, with the title Seismic Metamaterials with Low Frequency Wide Band Gaps Using Steel Barriers. Thank you very much again for sharing your expertise, and your topics are eye-opener and it is relevant for us to embrace the future challenges. Thank you again. Furthermore, I would really like to thank our MAHSA Chief Operation Officer, Prof. Ala Kesabarau, Dr. Guna, Miss Jennifer, Miss Teo, and Miss Rahimah from MAHSA Academy and Makom for their wonderful support to make this event successful. I would like also to thank Miss Rashidah and Miss Farah for doing their wonderful job as MC. And also I would like to thank the chairperson for the presentation session, which is Miss Zuliana, Dr. Azzimah, Mr. Mukram, Mr. Shazwan, Dr. Moon, and Mr. Kasirajat. Lastly, I would like to thank all the faculty members, the Dean, Deputy Dean, Head of Department, Program Coordinator, all lecturers, okay, from Faculty of Engineering and Built Environment and Information Technology for their support. And also for the conference committee, okay, I would like to thank for your support and your cooperation to make sure that Mi-TEC 2022 runs successfully today. Thank you again, and of course to all our paper presenters, thank you for your wonderful presentation. To the rest of participants and listeners, thank you for joining Mi-TEC 2022 conference. It has been great to have you in the conference. Thank you all. Have a great day and peace to you all.
Thank you, Dr. Hushnie. And congratulations for the wonderful event. Now, we are at the peak of ceremony, the one that everybody is waiting for, the award giving ceremony. So they are Best Speaker Awards. So 6 parallel sessions. So I would like to present the e-certificate for all the Best Presenter Awards. Best Presenter for Session 1 goes to Abu Snina Muhammad Mutra Hadiah for the title Portable Passion Health Monitoring System based on Internet of Things, IoT. Next, Osman Abdullah Musli Ahmad with the title Development of UHF RFID Tag for Agriculture Tracking System for the paper number 4. For Best Presenter for Session 2 goes to Nur Izzati Ahmad with the title Investigation of Lightning-Induced Voltage on Hybrid Solar PV Battery Energy Storage System with Single SPD Installation, paper number 6. Best Presenter for Session 3 goes to Yusuf Hel Muhammad Ibrahim, Development of Traffic Light, Traffic Sign and Lane Detection Using Computer Vision in Self-Driving Car, the paper number 15 title. Best Presenter for Session 4 goes to Analysis of Occupational Stress Using Temporal Data Mining Technique in Software Company, which is a Mekala Press Summit. Best Presenter for Session 5 goes to Abdullah Salah Muhammad with the title Missing Person Tracking System Using Satellite, paper number 2022. Best Presenter for Session 6 goes to Arun Kumar Rajendran for the title An Ultra-Fast or Optical Encoder-Based Photonic Crystal-Based Ring Resonators. Congratulations for all the winners. So others, you can try again next year. Thank you. Distinguished guests, ladies and gentlemen, as the saying goes, with every beginning, there is an ending. And now, Mi-TEC 2022 has come to its end. Once again, thank you everyone for gracing our ceremony with your presence, and we really appreciate it. Everyone, thank you very much for joining this Mi-TEC 2022. So inshallah, I hope to see you again in next Mi-TEC 2023. So I'm Nur Farah Ain. Until next time, thank you.